All right, so let's do some square root homework here. Starting with number 3. It says use each diagram to determine the value of the square root. Okay, so the square root is going to be the result when we do this operation, right? The square root of 0.25. Now, how can we use the diagram to help? Oh, there we go. Thank you. How can we use the diagram to help? Well, if I'm going to zoom in here a bit so you guys can see this a bit better. Well, the diagram, this is 1 unit here, it says. That's 1 unit. And so this little yellow square represents 1/4 of 1 unit. So this is actually 0.25 as an area. So if you remember how the square root and the side length of a square are related, the value of the square root, the answer you get, will be the side length of a square with that area. So if this is the area, what I'm looking for is the side length. So the square root of 0.25 is going to be the side length of this yellow square here. So what's that side length? If this is 1 unit, what is the length of this? Yeah, 0.5. So pause and think about that for a second. The area is 0.25 units squared, and the square root is the side length of that square, which is half of 1 unit, or 0.5. Okay, let's do this one. The letter B. All right, so this is, again, 1 unit. So we have 1, 2, 3, 4, and then by 1, 2, 3, 4. So we have 16 units here that are 16 squares. So that's where we get the 16ths from. 9/16 is this yellow shaded region. That's 9/16. So the square root of 9/16 will be the side length of this square. So this is maybe a little bit of a tricky part, but what is the side length of this square? Well, it's 3 units out of 4 units. It's 3 units out of 4 units. So the side length is 3/4. The square root of 9/16 is 3/4. 3/4 of a unit. See, here's 1 big unit, and there's 3 out of 4. Any questions so far? All right. Now, hopefully you're seeing that 25 and 5, right? And you're seeing the square root of 9 is 3, the square root of 16 is 4. Hopefully you're seeing those. This one here, these are in 25ths. So 1 unit is separated into 25 squares, and we have 16 of those 25 that are highlighted here. So what is the square root of 16/25? Again, you look at the side length. That is going to be 1, 2, 3, 4 out of 5. So 4/5 is the side length, and that is the square root of 16/25. Okay, any questions at all about number 3? All right, I don't know if using the diagram helps you. I don't really know, but anyways, I think just without the diagrams, it should be pretty easy too, especially with the fractions. Take the square root of the top, square root of the bottom. That's pretty easy. All right. They're not all going to look like that, I guess, but okay, let's skip to number 5. Now, number 4 you were to do, and number 4 asked you to write down perfect square numbers, right? So you have those written down in your book. You should also have those in your notes. So we're going to use those. We're going to use those values to determine what the square root of these numbers are. So this is root 36. So for A over here, I'll use a different color. Let's use black. Okay, so the solution's over here. For A, the square root of 0.36, what's the square root of 36 as a number? That's going to be 6, right? So I have 2 decimal places here, so that means the square root's just going to have 1. So 0.6 times 0.6 is going to be 0.36, right? 6/10 of 0.6 is going to be just over 3, 0.3. So it's all reasonable. All right, so let's do C. I'll just kind of run down the side column here. C, this one is going to be, what's the square root of 81? 9. So this is going to be 0.9, 1 decimal place. When I multiply 0.9 is the check. 0.9 times 0.9, that's 9 times 9 is 81. We've got 2 decimal places represented, so there we go. So when you check that, that's what you get. That's perfect. Just a quick note too, some of you, in marking your tests and quizzes and looking at your assignments, some of you are circling way too many things as your answer, okay? So don't do this as an answer for C. Don't circle the actual answer and then circle the result of your check, okay? You can't circle two things. Declare to me what your answer is. I don't want to see the original question as a circled part of your answer, okay? I know it might seem like a little thing, but we start to pay attention to little things in high school now. So if you want to check, I would certainly love you to check. This is what I usually do when I model this. I just write check. You can write that really messy if you want. I don't really care, really quick. But this is your check to see if this answer is correct. Only circle one answer. The answer that you determine is your answer, okay? Don't be circling a bunch of different things, okay? So again, just little things I want you to pay attention to. All right, 1 over 36. Ooh, boy, what's the square root of 1? That's a tough one, isn't it? The square root of 1 is? Yeah, it's 1. Actually, it's pretty easy. So the square root of 1 is 1. The square root of 36 is 6. Boom, done. I like fractions. Fractions are really good when you're doing square roots here like this. Okay? All right, and then G, so that was E. So let's do G over here. The square root of 64 over 100. That's going to be what? 8 over 10. Reduced to, and you should always simplify when you can, that's going to be 4 over 5. Okay? 4 over 5. So you could also simplify this fraction underneath the radical sign. A radical, you don't know what radical is. Underneath the root sign. You could do that first. So how could I simplify this? I could divide by 2. That would be 32 over 50. Could I divide by 2 again? Yeah, that would be 16 over 25. So simplest form, 16 over 25. And there, boom, you get directly to 4/5. So it's simplify first or simplify second. Either one is okay. Does that make sense? You could do the same thing with 36 over 16 too. I suppose you could simplify there first as well. Okay, everybody good with number 5 then? Other questions? All right, awesome. Okay, let's go to number 7. So number 6 was, I think they were asking you to write down perfect squares, or list the whole numbers from 101 to 400 that are perfect squares. So you're doing like 11 squared is 121, right? 12 squared is 144. So you've written all those down. You might have those in your notes already. That's great. You should get to memorize those. So for 7a, the square root of 169 over 16, I guess if we could take the square root of 169 and the square root of 16, we should, right? This is the exact same. So what's the square root of 169? 13. What's the square root of 16? 4. 13 over 4 is our answer. Yeah, improper fractions are totally fine. If you went the extra mile and said, hey, this is like, 3 1/4, is that what this would be? Yeah, we don't really worry about mixed fractions anymore in high school. Don't even, just improper fractions are totally proper in high school, okay? It's totally fine. That's totally fine. Okay, okay, C, what about C here? What's the square root of 256? Is that a perfect square? Yeah, it is. What's that? 16, good. Oh, and what about 361? That's a tough one. What's 361? 17, 18, 19, which one is it? 19. All right, can we reduce 16 over 19? No. 19 is prime. Do you guys know what prime means? What does prime mean? Anybody? Very good. It can only be divided by itself and 1, like evenly anyways. So 19 is like 1 times 19. There's no 2 times another whole number or 3 times another whole number. Doesn't work. It's only 2 factors. That's what prime means, right? Okay. Awesome. Okay, E looks pretty easy. The square root of 144, that's pretty easy. Just 12. Boom, done. What about G? Oh, this looks like a real tough one. Look at that decimal. That's crazy. I see 121 in there. Do you guys see 121 in there? Yeah, I see that. So I wonder if 11 will be part of this. So here's the thing. How many decimal places do we have there? And like 1, 2, 3, 4 decimal places involved here, right? If you had just regular 121, you would move that decimal place back 4 times. So in the past, 2 decimal places and you're multiplying something together, it goes to, like, square root is 1 decimal place. 3 decimal places is a problem because you can't half that number, but you can half the number of 4 decimal places. So let's think about that for a second. So the square root of 121 is 11. How many decimal places should I have in 11, do you think, to make this, to write this square root? I have 4 here. 2? Okay, let's try 2. So let's see if this squared, let's see what this squared is. I'm going to get my trusty, dusty calculator out here. And I'm going to check that out. 0.11 squared. Ooh. Is that right? Oh, it is right. Look at that. Doesn't have the decimal, the 0 in front, but that's 1, 2, 3, 4 decimal places I have there. So guess what? That is our answer. 0.11 is our answer. Now, does that help for I? I think it should. 324. What's that one? 324. So we said up above here, oh, I erased it, but 361 was 19, so 324 is under that. So 18, you guys good with 18? Okay, so 18, and we have 1, 2, 3, 4 decimal places here. So taking the square root should have half that number of decimal places, right? So I think it should be 0.18. So I'm just gonna check the actual square root of that number just to check. And you can check any of your work here with your calculator, no problem. What I don't want is just pump in these numbers here and just write down the answers from your calculator. I want you to think about it, okay? Because these patterns are what's important. Okay, but yeah, that's that. Okay, any other questions about 7? All right, apply. Okay, ooh, when you see that big apply word, it looks like, oh, we're stepping it up here now. All right, so let's just see which decimals and fractions are perfect squares. Explain your reasoning. So here's where we talked about some rules yesterday, right? The fractions, simplest form, if you can take the square root of the top and the bottom, and they're perfect squares, those should be good. They're perfect squares. What about the decimals? If we take the square root of the decimal, what should the answer look like if it's going to be a perfect square? Do you remember? There's 2 things we look for. Very good. Terminating or repeating decimals. So for example, okay, let's take a look. And again, we can use our calculator here. All right, so let's see. 0.12. Okay, whoops. I'm going to do square root here first. Square root 0.12. Now, what are your guesses before you hit enter? Do you think that's going to be a perfect square or not? Well, I don't like seeing the number 12 there. 12 is not a perfect square, so I'm not really sure about that. But who knows? Oh, let's see this decimal. Okay, so it looks like it fills up my entire screen. That's as many digits as my calculator can handle. And it doesn't look like there's any repeated parts or numbers there over and over. So this is a non-terminating, non-repeating decimal. So does it make sense that we would say this is probably not a perfect square?
Yeah.
Okay, very good. So that's not a perfect square. So I'm just going to cross it out. Boom, not a perfect square. Okay, if you go over to B now, ooh, I like 81. I like seeing 81 there. That's really good sign. And how many decimal places around that 81? So there's 2 represented, right? So can we take the half of 2?
Yeah.
Yeah. So this is looking pretty good. Now, again, let's just check with our calculator and see what Mr. Calculator says. Oh, square root of 0.81 is 0.9. Look at that. This decimal is terminating. It stops. It's just 0.9, and then there's no other numbers there. That's terminating. That's a very good sign. Yes, this is a perfect square. Okay, what's your guess on C? We shouldn't have to check this one. Yes or no? Shout it out. Yes, it is. 1.69. Okay, I see 169 there, which I know is a perfect square number. What's the square root of 169? 13. Okay. And we have, looks like 2 decimal places represented here. Okay. Well, let's think about that. What if I did 0.13? Would that work? If I squared that, I should get 169, but then it would be 4 decimal places. Okay. What about 1.3? if I squared this, that should be a number that's just a little bit greater than 1.3, like 1.4 or 1.5 or maybe 1.69. So if I have one decimal place represented in this number here, if I square it, I should get 2 decimal places. Ooh, which is what I have. So we're thinking maybe yes, right? Well, let's just double check. 1.69. 1.3, look at that. Terminating decimal, this is definitely a perfect square. Okay? All right, E, what about E? Let's do E together. 9 over 12, perfect square, not perfect square. But, what am I gonna say? We should probably try and simplify this fraction first to double check, right? Can we simplify this fraction? Can we divide both by 3 maybe? Okay, so let's simplify it. Divide both top and bottom by 3. I get 3 over 4. Now, are these both perfect squares? Eesh, no, that 3 isn't. So when it's simplified, if I don't have perfect squares, I'm thinking probably not. Let's check. Let's check. So 9 divided by 12 is, square root. That's what I want, square root of the answer. I always forget to put that square root. Okay, ooh. Big long decimal, fills up my entire screen, no repeating parts at all. So it looks like this is non-terminating, non-repeating decimal. So you're right, this is not a perfect square. One more thing I'll show you, okay? Can we make a square that has 12ths? No. I can't even make a perfect square that has 12ths. Let's say, let me make a rectangle with 12ths. So 12ths, you know what I mean? 1, 2, 3, darn it. Okay, so I'm not very good at doing that this week. So let's say this is my rectangle and I need 1, 2, 3, 4, but I need 3 separations here. Okay, so I've got 12 there. That's terrible. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I've got 12 there. Now, is 9 out of 12, can I shade 9 out of 12 of these things and make a perfect square? Well, I can pick 9 out of here, I guess. I can pick 9 out of here. Now that looks like to me a perfect square. But does this follow the pattern of all of the other diagrams that we've had? No, it doesn't. It doesn't. Let me just see here. Actually, it was just, I think it was up earlier in that page, maybe. Oh no, where is it now? Give me 1 second here. Give me 1 second. So if we go back to some of these pictures, there we are. Maybe even further. Yeah. Okay, so look at these perfect square numbers that we drew here. There's always a row of squares on the top and a row on one of the sides. It kind of always works like that. And even, I think even, with the pictures that we drew here, see? There's rows on the side and on the bottom. So there's a row here and a row here. So if it's going to be a perfect square, this is not going to work to draw it like this. There would have to be, look at this, there would have to be a row here as well. So that would actually be 9 out of what? 9/16. Now that's a perfect square. You see? So this one is not. So remember, if you like drawing the diagrams, if you can't make a perfect square out of the number on the bottom, then you've got a bit of an issue there. Okay, that's not going to work. All right. Okay. Is there one from number 8? The rest of these that you want me to do? I'm just going to do maybe one more. H. All right. Ooh, 75 over 27. That looks nasty. Yeah, let's do that one. So 75 over 27. Now these are not perfect squares for sure. But can I reduce this fraction? I can, yeah, because I can divide both these by what? 3. So if I divide by 3, both top and bottom, I get 25. Ooh, that looks good. And 9. Ooh, that looks good too. Look at that, reduced. I have a perfect square on top, a perfect square on the bottom. So guess what? The square root of this is going to be 5 over 3. So 25 over 9, or 75 over 27, is a perfect square. Good to go. Okay? I'll maybe do k. Actually, I'm looking at k here. That might be a little bit tricky for you, so let's do k. So this is, as a fraction, it's 25 over 10. You guys see that? Now, are these perfect squares? Not both of them. No. But can I reduce that? Well, divide by 5, I get 5 over 2. Are these perfect squares? No. Now, I do notice, though, that 25 is a perfect square. So, obviously, 5 times 5 is not 2.5. What about 0.5 times 0.5? Does that equal 2.5? Nope. That doesn't. It equals 0.25. See, 2 decimal places multiplied together gives you, or 1 decimal place each multiplied together gives you 2 decimal places. So it looks like we don't have a number that multiplies to this, but let's get on our calculator and just double check. 2.5, oh my goodness, I always forget this. Square root, I have to do first on this calculator. Square root 2.5 is, oof. Wow, there's lots of 8s in there, but this is definitely non-repeating, non-terminating, so not a perfect square. Okay? Simplest form of the fraction, too, 25 over 10, right? We said this was 5 over 2. Can you make a perfect square with 2 squares? No. You can't. So even drawing that's not going to work. So this one is no. Okay, that's a long time on number 8 there, I guess, but does that help? All right. So I've got number 9 up here as well. Let's take a look at number 9. Okay, this one's a bit different. It says calculate the number whose square root is. So this is the result when we take the square root of something. So square root of what gives us 0.3 for A? So all we do is we take 0.3 and we square it. We just multiply it by itself. So what's the number under here going to be for A? So is it 0.9 or is it 0.09? It is, because 1 decimal place, when we square it, gives us 2 decimal places. Very good. So your answer is this answer right here, because it's 0.3 squared. So calculate the number whose square root is. So this is the number that has a square root of this. All right, B. Now 12 is not a perfect square, but again, this is the square root. So all we have to do is square 0.12. So what do we get? 12 squared is 144. So I need to have how many decimal places when I square this one? I've got 2 decimal places there. So when I square it, I should have 4 decimal places. So let's put 144, and then I got to go 1, 2, 3, 4 decimal places. And again, on your calculator, it should be pretty easy to check that. 0.12 squared is 0.0144. Okay? All right, let me skip down to some fractions here. So E, oh man, this is like baby stuff. This is so easy. All you do is what? All you do is what? To get the number that this is the square root of. We want to square this, right? So what's 2 over 3 squared? 4 over 9. 4 over 9. Done. Done. Easy. What about H? Let's do H down here. What's the number whose square root is 2/5? 4 over 25. I like it. Pretty easy, hey? So for 10A, without a calculator, what you do is you turn it into a fraction and then try and work with the fraction. So 100 is a perfect square. Is 1225 a perfect square? Yeah. Is it? Okay, what times what is 1225? I don't, do you have that? You don't have that on your list. You only have up to 400, right? We can reduce it. Okay, there we go. Let's reduce it because we don't know what that one is. Can we reduce it? Well, this one ends in 25, so we can certainly divide this by 25. I wonder if we could divide it by anything bigger. Well, let's do 25. So how many groups of 25 are in 1225? I think it's 49. 1225 divided by 25, I think is 49. So that's going to be 49. And what's 100 divided by 25? 4. Oh, now this looks really good, doesn't it? Because 49 is a perfect square, and so is 4. So we have 7 over 2 is our answer. Or 3.5, I guess, is what 7 over 2 is. So you can do fraction or decimal here. But that's the way we do that without a calculator, and you should know how to do that without a calculator. You should be able to explain and show these kind of steps here, okay? So don't just pump this into your calculator and move on. You should be able to show these steps, and I will ask you to show your work here as much as possible, because that's an important thing we want to do in high school. All right, so B, 30.25. Let's do the same thing. Can I write that as a fraction? That's 3025 divided by 100, isn't it? I could do a similar thing, divide this by 25. So let's see. Do you know how I do this in my head? I go 30 times 4, because groups of 25, there's 4 groups of 25 in every 100. So if I have 30 hundreds, how many 25s? I have 30 times 4. So what's 30 times 4? 3 times 4 is 12. 30 times 4 is 120. And then one more group of 25 here. So let's see. Is it 121? Let's check on our calculator. 3025 divided by 25 is 121. Divided by 25 here again is 4. That's awesome. Both perfect squares. The answer is 11 over 2. Or what's half of 11? 5.5. Okay, I'll let you do C and D on your own, whatever, for number 10. Number 11. Okay, number 11. Let me walk through parts of number 11 with you anyways. This says write each decimal as a fraction. Which fractions are perfect squares? So as a fraction, 11a Roman numeral number 1 is 36 over, well, I guess 1. It's 36.0. So are both of these numbers on the top and bottom a perfect square? Anybody? Yes, they are. That's 6 over 1. Just 6. Good. That's easy one. 2. 3.6. Well, that's 36 over 10. Let's reduce that. 18 over 5. Are those perfect squares in the reduced form? Nope. So it doesn't look like 3.6 is. And you keep doing that same thing. So this is 36 over 100. Are those perfect squares? Yes. Yeah. And my program just crashed on me. Where were we? This is 36 over 100. Yep, those are both perfect squares. And so on. So you keep going and do that. What patterns did you use? So just a brief explanation on what we did for that. Turn it into a fraction, simplest form. Are they perfect squares on the top and on the bottom? You didn't have to see any? Just A and B? Okay. Okay. All right, one more, 13. I'll just go over 13 with you. When you see these questions are assessment focused, this kind of like covers a little bit of everything. That's what those questions are supposed to be for. If you can do this question, you basically can do everything you're supposed to do in this section. That's what that's supposed to mean. So which letter on a number line below corresponds to each square root? Okay, so 1225, well, actually earlier on in your assignment, we found out what the square root of 1225 is. So if you did your homework, you could probably look back there, right? Let's see, that's 10a. So 10a is 3.5. So guess what? Where's 3.5? That's C. So that one is C. 3.5. 121 over 25? Well, that's 11 over 5, which is just over 2. That's 2 what is it, 2? 2.2, so that's A. So this one is A, and so on. So convert these, find the square roots of these, and then place them, find their corresponding letter there. I'll do this last one with you because this one looks a little funny. 841. Boy, is that a perfect square? Well, I wonder if we could reduce that Oh, 841. Is 841 a perfect square? You only have memorized up to 400, right? So this is a little bit more than 400. Can I simplify this fraction underneath here? Well, 25 is tough. The factors of 25 are 1, 5, and 25. And I know if this number here is not a 0 or a 5, this number does not divide evenly by 5. So I can't really reduce this. So I guess we're just, let's go ahead and ask Mr. Calculator. Can we take the square root of 841? What does Mr. Calculator have to say? Oh, look at that, it's 29. So guess what? This is actually 29 over 5, which is 5 4/5 or 5.8. So look at that, 5.8 D. Now, another way that you could do this is using your powers of estimation. I'll just conclude with this, okay? So we have, everything else has been taken care of here, so we know which one this one is if this is the last one you do. However, 841, okay, so this, what's a, how should I say this? What you could do is find out approximately what this decimal is. So 841 divided by 25. You could kind of guess what decimal this is, which might help you. So let's see, 800 has how many 25s in it? 800 has how many 25s in it? That would be 8 times 4, 32. So it's going to be 32 and then one more 25, so 33. So this is going to be just over 33. So 33 point something. Let's say 0.2. Well, do you know what the square root of 33.2 is? Maybe not. But do you know what the square root of 25 is? And what the square root of 36 is? You do, because these are the perfect square numbers that are just below and just above this number. So you could guess that this square root is somewhere between 5 and 6. So this number is going to be between 5 and 6, and there's the only one that's between 5 and 6. So you could estimate that way a little bit, and that's a good way to do it without using your calculator as well. Okay. Any other questions about these ones? I did ask you to do a few more for your assignment, but I'll let you work on those. You guys good?